5 times 5 is?
25.
Yeah. Hey folks, welcome out there. You are with us. You are on it today. You are with Mathline, and we're so glad you're here. I'm Ernie Roberts. I'm your host for this afternoon's specialized segments. Notice I said that. This is not your typical day for a specialized segment, but it is a holiday this year, and we want to observe that as we go through the process of our show today. However, as you know, it is still about math, and that's what we're going to do today. You don't have to take any phone calls. Nope, can't call in today, but you can leave us messages as you always do. And you know what else you can do? You can sit back, relax, get some pencil, get some paper, maybe a calculator, and let's do some math, all right? And guys, let's see what our topic of the day is going to be for us. The power of one. Today we remember the life of Dr. Martin Luther King Jr. and his passion, leadership, and faith. For those of you watching today's episode of Mathline, we celebrate the number 1 to remind you that one person can make a difference in the lives of so many, as Dr. King did. Today's show topic, The Power of One, reminds each one of us that we too can make a difference in this world. So there you have it, my friends. We are the power of one today. Going to salute that number 1, and let's go to it. Let's see what we've got coming our way. First things first, as I said, the 1 is such a powerful number, not only in our lives, not only in the life of Dr. King, but also in our math world. Describing the set of natural numbers. You say, Ernie, what's that about? What are the natural numbers? We've never heard of that. Well, some of you have, some of you have not. But they are just a nice, I don't even say fancy word, it's an alternative word for the counting numbers. So what's the first natural number? Number is 1. After 1, we add 1 more to it. Oh my goodness, we're at 2, 3, 4. You get the idea. So again, we start with 1, we pick up, we go, and you know what? It goes forever and ever. I remember when I was young, I always wanted to try to count to 10. It was exciting. Count to 100. And after 100, I'd start counting and get bored. You know, it got kind of a long way up there. So we started counting by 5s and 10s and so forth. But we all started with the number 1. And that, my friends, is what we've got to deal with today here. We're going to talk about the power of that value of that number 1. There it is. 1 hand, 1 finger, 1 mind, 1 vision. So many 1, 1, 1s. You hear it all the time. So let's take a look. Let's go for another thing here. And we're going to see some more examples of where in this world we use the math number 1. All right. How about it? Let's start with our next one here. What is the identity element of multiplication? Now you say, whoa, you're getting these fancy words. These are properties. And by the identity element, we simply say what number, when we multiply, will give us the same number back. All right? You say, well, we'll say that again. In other words, I start with a number. Maybe the number is 7. And I want to know, what am I going to multiply to keep 7? Now, we have a few people out there that think 0 works that way. That's when you add. All right? 7 plus 0 gives you 7. But when we multiply, that number that we're looking for is 1. Does it work for everything? Of course it would work for anything. Or I wouldn't call it an identity element, would I? Well, let's see. Let's pick a few more here. We'll try a few more. How about it? 1 times 15. I get 15. Think big. Think big. Oh, goodness, it's this year. 1 times 2019, the year. Still get 2019. So again, that's the identity. That's the identity element. What about negatives? Well, not -1, but let's look at +1 times a negative number. It still works. Times a -20, let's say. That's going to give you -20. So there you have it, the identity element hanging out there. And even when we put a -1 in there, well, we're going to get the same number. We're just going to be changing signs. All right. So if we had it, for example, we took a -1 times that 7, we would get the -7 this time. All right. So it's still feeling of an identity element. There you just got to watch your signs. And of course, what is that? A negative times a positive. It's going to give you a negative. And on down here, how about if I put a -1 times a -20? Boy, does that change everything. Then we go positive. But still, 1 times 20 is 20. 1 times 7 is still 7. Watching the signs. So that's what we call an identity element of multiplication. Remember what I said? Oh, by the way, does it work for division? It does. As long as you're dividing numbers by 1, you're in good shape. You're going to get the same thing right back there. So it's a very powerful little guy there, all right? our number 1. Powerful, powerful. So what we got else coming our way? We've got the identity element working. You know, when we have the identity element, we've got to talk about what happens when we run a reciprocal in there. So let's take a look at that. The product of a number and its reciprocal is always 1, no more, no less. There's one exception. You cannot have a 0 because 1 over 0 makes no sense, all right? So any number, I should say, any number except 0 and its reciprocal will always be 1, no more, no less. In fact, when we really get down to it with the reciprocal of 0, it's kind of hard to figure out anything that's going on with that. So just to avoid that part. Now, from here, let's see what happens. Let's take 3/4. There we have it. Okay, that's a nice old fraction. And we multiply by its reciprocal. How about it? 4 over 3. And that's a powerful moment because we don't have to cancel here. We can do that. We'll do it in just a second. But 3 times 4 is going to give us 12. And we have 4 times 3, which gives us 12. And you know what? A number divided by itself always comes out to 1 either, unless you're playing the game with 0. Then it becomes meaningless, okay? So there we have it. We have it kind of going for us there. Some of you are out there saying, oh, Ernie, could we have done some cancellation beforehand? Sure we could. Let's look at it again. 3/4 times 4/3. Let the 3's cancel out. Say goodbye 3's. There they are. What happens? Oh, we got 1's left over. You know, some of my students forget that there's no number there. They think it's a 0 and it's gone. They know better after about 1 or 2 corrections on a test paper, right? And then we've got 4 and 4. We will let those cancel out. And there's still 1's there. So when we end up, my goodness, it's 1 over 1. And we've still got our power of 1. So a product of a number and its reciprocal is always 1, no more, no less. Now you say, what about negative numbers, Ernie? What about negative numbers? Let's say I'll go with negative, let's make this a little more interesting. Negative 1 1/5 times, I don't know, what's negative 1 1/5? What are we going to multiply it by? I think we want to multiply it by negative 5/6. Let's see if it's going to work. Remember how we make an improper fraction? Because we have a mixed number here. So we're going to take it, I'm going to say that's the reciprocal. Y'all can hold me to that. But we're going to check and make sure. So we say negative 1 times 5. Negative, yeah, there's negative 5. We'll add another one to that. We're going to get a negative 6 over 5 times that negative 5/6. Now remember, we don't look at this negative until the final moment. So we got 1 times 5, which is 5. Add 1. Then it makes a negative 6 there. So be careful with those things. Now here we go again. Let's watch these numbers. They cancel beautifully. There's 5s. That gives us a lot of 1's. Here's 6's. They cancel beautifully. They give us a lot of 1's. And we got the negative times the negative, which is going to give me a positive. And you know what I end up with? That grand number 1. So here we have a lot of options. We'll drop the lower third out of the way there for a minute, guys. Thank you. What happens if we take a whole number, like a 6, and I want to get its reciprocal? So what I need to do first of all is drop that 1 under the 6, and then I can make the invert. I can make the reciprocal, which would be 1 over 6, or 1/6. And you see the game plan here? Say goodbye. Say goodbye to those 6's. You get 1's again. And that's the story. There's your power of 1. Flip it the other way, and by that I mean let's make the 1 over 4 come first or something like that. How about 1 over 4 is what I chose. What's its reciprocal? It's going to be 4 over 1, okay, or just number 4. And again, watch and see, they always cancel out, leave you with 1. As I said, as long as you don't put a 0 in those denominators to make that value of 0, okay? Or in a denominator. You can't have a 0 either place on these if you're going to start multiplying them together. That would be a problem. Yeah, you can say 0 over 4, that's fine, but when you put 4 over 0 to represent its reciprocal, you got a problem, okay? So that's why we say the product of a number and its reciprocal is always 1, no more or less, as long as that number we start off with is not equal to 0. So everybody good on that? You got it. Powerful number 1. There we go once again. So why do we do that? Why do we worry about the number times its reciprocal? People kind of wonder, well, why did you go through those problems, Ernie? It is cool if they get 1, all right? Or in some cases where we threw a negative times a positive, we changed signs, but we still got 1, either negative or positive on it. So let's take a look at where we do use these little guys to help us out, all right, to the reciprocals. So I've got a couple, actually I've got a thruple, I guess, 4 of them here, good old equations to solve, all right? And we've got fractions there. And it says 2/3 of something gives me 21. So remember I said let's play the reciprocal game. So I'm going to write this down here just where it looks a little bit easier on our eyes, equals to 21. And again, I'm talking about 2/3. That x is basically, if it were floating around, it would be floating actually in the numerator, not with the 3, but it's actually 2x over 3 if you really want to get picky about it, all right? But we're just going to say 2/3 x, and we're going to know that the x taps itself in with that numerator. How do we clean that up? Well, some of you said, well, Ernie, could we multiply 3 times 21? Yes, we could. And then could we divide by 2? Yes, we could. Or, you knew there was an or coming, right? Or we can take the reciprocal of that 2/3 and multiply by the reciprocal. Now, some of you are going, well, you have the same answer? We'll find out. We certainly will find out here in just a second, all right? So we're going to take that 3 over 2, run it through there. And why did we do that? Because the 3's go away and our 2's go away. And now we end up with, it looks like, well, 63 over 2. Now, I know some folks are saying, well, it's okay to leave it like that, isn't it? How about it? We can also say, how about 31 and 1/2? Or if you like those decimals, 31 and 5/10, 0.5 out there on the end. But that's what you comes up with, right? Goes in there 31 times with 1 left over. And that's okay, that's okay. And so you say, well, will it check out? If you take 63 over 2 times 2 over 3, yes, you will. You'll end up with 21 out of that. Because the 3, that's the way it's going to work out. So have fun with that one. Yes, that's a good little problem. And they don't always have to come out even, do they? So let's look at our next little guy over here. How about it? Move over to this side here. We got 3/4 of y equaling negative 21. And it's time to play reciprocal game again. We're going to multiply both sides by 4 over 3. All right, you got that? 4 over 3. Whoa. Over here we're going to take 4 over 3. I'll drop a 1 underneath for good measure. And again, notice the power of 1 right there. We have 1y left over. Or just y. That's the whole idea. These came over, back over here. We had 1s popping up everywhere. There they are. And life was good. Now, let's do a little, we can cancel. Goodness, thank goodness for that. All right, we can get 3 divided into 21. It goes 7 times. Oh, there's another 1 popping up there. 1s are great numbers. You know that? We love them, don't we? And that looks like a negative 28, which seems to be working fairly well there. All right, that's what we're going to have. Now, playing on here. Oh, goodness, we just keep playing on, don't we? Let's look at this one here. We've got a negative 3/2. Again, we're going to make the power of 1. Let's put a negative 3/2 down there so everybody's with it. Equals 12. Now, multiply through by a negative 2 over 3. A negative 2 over 3 there. Put a 1 in there. And let's see what cancels out. 3's go, the 2's go. And, negative times a negative, of course, we're going to get a positive. It's going to be a 1c equals, it looks like, oh, by the way, that's 1y equals, you know, everybody go back up there. Identity element. Somebody said, Ernie, there's an identity element there. You know, you're right. That is going to allow us to keep that y to be equal to negative 28. Just jumped a little bit on us. Let's go back to this one now. We're back in tow here. What did I just use? A 3 here, right? It's going to give me a 4. And it looks like I've got 4 times negative 2, and I've got another 1 popping up. I love those. And we've got a negative 8. Identity element time. Move it through here. C equals negative 8. Now, some of you are saying, Ernie, could you have done that? You had 1s up here, right? We had a lot of 1s. Again, that's why we're using the power of 1 today, right? Over here, back up to this problem, I put some 1s in there. I could have put a 1x there. I just didn't, okay? But I decided over here I'd put a 1y. Because, again, theme of the show, power of 1, yes, You could leave out the step 1c. Yes, you could leave the step 1y. But today we celebrate 1, so there you have it. Now, one more quick problem of this nature. Let's bring down 6/5 of p. Oh my goodness, we want it to equal 1. We want to find the p-value that's going to make 1 happen for the final answer here. So again, let's do the reciprocal. And you know, I really like to say this once in a while, and I figured I'd wait for the fourth problem. Remember, whatever you multiply the left side by, that reciprocal, you've got to do it to the right. And that's what we've been doing. I kind of took that as for granted that you knew I was doing those. Now you know. Balance, left and right. Got to do both. Sometimes it gets just old hat and complete nature. You just forget about it. All these ones are popping up again because they cancel. All that beauty there. And this time we got the identity element working for us. My goodness, we've got a 1p over here working for us. We got ones everywhere. And that's going to end up giving us, though, a final answer of 5/6. Does it work? 6/5 of 5/6? Multiply them. You get 1. Everything cancels, correct? That's great. And by the way, we come back and check this one, put an 8 in there. I want to go back and check this one up here because some of you are going, Ernie, that's a crazy answer you got. All right, so let's take a look at it. I've got 21. Let's see. Is it 21 equals to 2/3 of, what was that number we got? That, goodness sakes, it was 63/2. We're going to take it back to before we made the mixed number out of it, okay? And what happens there? I see the 2's cancel. I see the 3 goes into 63 21 times. You know what's left? A bunch of 1s. 21 equals 21. So my friends, even though the fraction wasn't very pretty, at 31.5 or 63/2, it still goes back and checks very nicely into your statement, into what you started with. So that's what we wanted to make sure we got through, we're able to do. And by the way, when you have a 2/3 like that, it's kind of hard to make that 31 and 0.5 on there, or 5/10. It's much nicer to use the fraction version to check it out. FYI and FY mine, okay? All our information there, we've got it. So again, that's some of the basics, some of our basic moments there. Now, you've heard about, speaking of power, well, we've got to talk about how do we get 1 when we raise an expression to a power. So let's take a quick look here. It says any number raised to the 0 power is equal to 1, except, of course, the case of 0. All right, so any non-zero number, we should probably say, raised to the 0 power is equal to 1. So let's take a look. 7 to the 0, you know what? It equals 1. Now, how do I know that? Let's take a look. Let's suppose I had 7 to the 3rd and 7 to the 3rd as a fraction. All right, a lot of people always wonder, how do they ever decide that something to the 0 power actually equals 1? I want to put 0 down. Some of you say that. Yeah. Well, it's 1, but why? Here's why. And this is going to be funny because what's going to come up with here, this is 7 to the 3rd power. Let's see, on the calculator, I think it'll tell me what that is. I made it kind of complicated, didn't I? Not a divided by yet, sorry about that. We're going to raise it. 7 to the 3rd, which is going to give us, wow, 343. That's interesting. Well, you know what? It's not going to change for the denominator, so it's still the same thing. Well, what do we know? A number divided by itself is equal to 1. You say, well, that's fine, Ernie. So what does that have to do with the 7 to the 0 power? Let's go back to the rules. Right here, remember, like bases, subtract your exponents. So we're saying 7 to the 3 minus 3. Drop out the bottom for me, guys, and we're going to finish this one off at 7 to the 0 equaling, of course, 1. That's why it works. Basically, take the like bases, subtract those exponents, and you're going to get your expression to the 0 power. Okay? It's another reason why we can't have zeros in there. Doesn't make any sense because 0 to any power is going to obviously give you 0. Now, what about this one? I put a parenthesis, and here I did not put a parenthesis. You say, well, Ernie, what's the difference? Like some of my students, there is no difference, and at least you tend to not remember that there is a difference. But I remind you again, and that's the way it works. I said it's going to be equal 1. All right? Any number, it's inside a parenthesis for a reason. This means we're taking that negative to a 0, which is an even power, which is going to give us the positive form of this. Now, what happens if I don't have a parenthesis? It's like move the little negative away. We got to take 4 to the 0, which is 1. Now we put in the negative. So again, sometimes I got to teach a little positives and negatives. We're talking about the power of 1. There's also that -1 version, and it's a pretty powerful guy too, all right? Pretty powerful thing going there. So again, notice what we have here. If it's in a parenthesis with a negative number, it will come back to 1. If we don't have it there, it's going to give us a -1. And let me guarantee you, let's go to the calculator, it's going to do it too. So let's take a look at that one real quickly. We're going to take 4, we're going to raise it to the 0. That's an exciting moment, isn't it? Not everybody gets too excited. Does the calculator know? Of course it does. Now, what happens if I put the parenthesis there? Let's see if we can get there. We'll put the parenthesis of a -4. We'll close that parenthesis, and we'll raise it to the 0 power. And press enter. Smart calculator, it knows it's 1. Now remember what I said? If we take away the parenthesis and just put -4 raised to the 0, my goodness, what happens? Everybody ready for a -1? Drum roll time. There it is. So again, parentheses make all the difference, but that 0 power comes to give you either 1 or -1, depending on how you place your parentheses. So that's your story on that one, and pretty good set of answers there. So let's see what happens. Got a couple of more aspects where we see it, actually a lot more aspects. We can only touch the iceberg where 1 pops up. We could have worked equations all day long, got an answer of 1 too. But we want you to see a few more items where we have. Let's go to a little world of trigonometry. Some of you are out there that you are with us and you are into that pre-calculus mode. Sometimes you're even doing this in geometry and algebra too, especially nowadays. And you've got this little thing called sine squared plus cosine squared equals 1. And it comes back to the right triangle relationships. It's a Pythagorean relationship, if you will. So let's take a look at what we have going on here. And in a right triangle, I'm just going to go with A, B, and C. A really kind of quick notice here. And we know in a right triangle, we got that grand formula, Pythagorean theorem, A squared plus B squared equals C squared. And everybody goes, well, that's nice, Ernie. It is. It is. It's a great little thing. And we all know that, right? We can work with that. Now, what do I want to do? I want to get 1 here. So how do I do 1 here? Well, we divide by C squared. Why not? Why not? And we'll put it here and there. And all of a sudden, we're going to come up with an identity that equals 1. Now, right now, see, we got A squared over C squared. Well, let's do something about that. I'm going to put that A over C, and I'll put a little squared there, okay? And then I'm going to have to really jam up this B over C, and we'll put a little squared there. But we squeezed it in there, didn't we? Now, go back to your Chief SOHCAHTOA moment, all right? You've got the, let's say we've got this angle right here, and we're going to call that angle X right there. That's the deal. So we're going to notice that A is opposite of X, C is the hypotenuse, and you know what opposite over hypotenuse means? Some of you go, what? Remember good old SOHCAHTOA. And that told me that the sine and opposite and hypotenuse go together. Here the cosine and the adjacent leg and the hypotenuse go together. And for those of us who like tangents, that's what TOA stands for, opposite and adjacent leg. So what have I got here? I've got A over C, which, you know what? That goes with the SOH, not to ka, but the SO. And that's going to be our sine X squared. Aha. How about this one? Adjacent over hypotenuse. That's going to be our cosine squared of X. And equaling out to 1. How about that? And that's an important identity in the world of trig, and it's how the unit circle completely works. So can I cut away from you just a second here, guys? Thank you. Got one more I definitely want us to get up here. And let's do this one to close up the show today. What happens if we take 1 and double it and take our new number and keep doubling it and doubling? So, for example, we start with 1 and we add 1. It's going to give us 2. Now, let's take that 2 and add 2. That gives us 4. Let's pick up that 4. Add 4. We get 8. It's really what's going on here. Once we can start with one number here, but we pick up another, and then we start keeping this rolling effect, that's how we make a difference, folks. That's how we do it. Dr. King was one who started as his own. He spread his word. He added more people with him, more of his beliefs, civil rights, all the good things. More and more people got in there, and before you knew it, you had some amazing movements that still we are celebrating what he's done today. So again, power of one. Dr. King made a difference by using that power of one and keep moving up. Now, each of us can do so too as we go through our lives, make a difference. We're all good, help each other, be with each other, and also do the things that are right and be good and make sure everybody's treated in equal manner. Thank you for tuning in today for Mathline, Martin Luther King Day. Enjoy the rest of your holiday. We'll see you next time.